Dear participants, in this session, we will be going with experiment number 4 and 5 of section 2 IAVOC 105. These experiments are related to electrical technology theory coursework, and in these experiments, we will be studying the behavior of three-phase circuits with balanced load and unbalanced load. As we know, the basic characteristic of balanced load is that in case of a star circuit definitely or a Y circuit, that there will be no neutral current. That is, the neutral current amount will be zero. However, in case of an unbalanced load, definitely there will be some neutral current. So there is a current loss, and an unbalanced circuit, as we have already studied, is never desirable, because in case of an unbalanced load we can have damage of the equipment or device. Definitely it leads to loss of quality of power, and if the case is very critical and severe, that may damage onto the supply side also. Therefore, unbalanced load is never expected. Now let us see how we are going to perform the experiment and measurements. You can see there, for this experiment we will be using this load bank. This is actually a resistive load bank, and you can find uh, these are the loads, these are the switches. If I connect each and every switch, resistive load is connected to the phase. Now these loads are connected in between. You can see this is red phase and this is neutral. So the load is connected in between these two terminals. So once I keep on increasing the load, this load is reflected against these two terminals. Now you can see here the black terminals, that means the neutral terminals, they are all connected, as you can see here, through these black wires. Okay, so there's no problem, I will just go for that. Yeah, that means when we connect these 3 points with the supply, this will be a simple star circuit. The star circuit with 4 wires, because there is the presence of neutral. Now in order to feed the circuit, we will be using an auto transformer. You can see here, this is the auto transformer, and it's a 3-phase auto transformer. So that's a very interesting equipment. You can find here that you can feed this device with a 415 volt input, and at the output you can get up to 470 volt. And the transformer, you can see, since it is an auto transformer, we can have variation in the transformation ratio, and therefore you can make the transformer work as a step down transformer or a step up transformer. Therefore we can have desired output across these 3 terminals. For this particular experiment, we will be having 440 volt line to line voltage, okay, and 220 volt across each phase. That means phase voltage will be 220 volt and line voltage will be 440 volt. Line voltage means voltage between R phase and Y phase, voltage between Y phase and B phase, and voltage between B phase and R phase. So that we will do first. So let us see how we are going to connect. As you may please find that these are the 3 wires, these are the 4 wires that are coming from the 3-phase supply of this laboratory. So here I will be connecting them. You can see I have connected the red here, blue here, yellow here, and finally this is the neutral. Okay, so on this side the connection is ready. Now this is the input side. Now we have to connect the output. As you may please find that we have already connected the jumpers for red phase, yellow phase and blue phase, that we will be connecting here. So here I am connecting the red phase. You can find here I am connecting the yellow phase, and finally I am connecting the blue phase. That's it. Now we have to connect the neutral, because we want to measure the neutral current. You can see here that we will use a separate jumper wire for neutral. This is a bit dangerous because you should not use such type of jumpers, but fine, I couldn't find some better one with me. So this is what I am connecting here. So now you can see the circuit is completely ready. Now what we have to do, we have to simply rotate this. This is the auto transformer knob, three-phase auto transformer it is actually, and by rotating this knob we can set the voltage that we desire for the circuit. Alright, so I'll put this here so that now we can focus on the operation. And this particular tongue tester we will be using for measuring the current. You can see, in order to measure the current we need to connect the ammeter through the device, through the circuit. So I am to make a break in this circuit, in the neutral circuit, and there I am to introduce the ammeter. Now in order to avoid such a break in an high power AC circuit, normally a tongue tester is used. So in order to measure the current, you have to just put it across the wire like this, and you can simply measure the current like this. Okay. Now we will first set the voltage. So I will be putting this in the range of AC voltage. What I have connected right now for this thing, you can see here. I will be putting it here maybe for a better view, or this is a better view, definitely larger one. Now what we will trying to do, or we can, I will see if it can be made better. Yes. Now you can see it's very clear. Okay, so what we will be doing, we are first trying to see the phase voltage. So we will be connecting this multimeter terminals or tongue tester terminals. Now it is in voltage measurement condition across one phase. Okay, so this is the red phase and this is neutral. So now I will charge the circuit and I will be setting 220 volt. Okay, so now you can find I will be simply rotating the knob, and you can find the AC voltage is increasing. As we had discussed, I will keep the phase voltage to be 220 volt. Alright, now once it is 220 volt, we will see what is the value of line to line voltage. Okay, for that I will first switch off the power. I will connect the voltmeter across two lines. Then I will again switch on the power. And now you may find it is somewhere near 400. Alright, so this much we are working on. So now we will be introducing the load. Uh, while introducing the load, we will be simply disconnecting the voltmeter because we no more require that. We have set the voltage that is required for our experiment. I will be disconnecting these knobs. As I had always told you and warned you rather, that while performing practicals with electrical equipments, you should be very careful, otherwise you might electrocute yourself. So now we will be measuring the current so that we can see it properly. How this is the wire, that is the neutral wire. This neutral is connected to the neutral of the supply, that is the auto transformer side. So I will be putting it in ammeter. You can see it is in 20 ampere AC range. Okay, you can find it. It is AC 20 ampere range and we can easily have the reading. Now see, now I will be introducing the loads. Now I will be introducing the loads, and you can see here for that I am to put this mains on. Now we will be having same load across these three phases. So I will put this one. This is the load bank for red phase, load bank for Y phase, and load bank for blue phase. So now you can see in three of the phases, or in three of the load side, you can see here that the amount of load is exactly same. All right. Now we will see here that the neutral current is 0. As you can find very easily, the neutral current is 0. All right. You can find. You can see the neutral current is 0. Now what we will do, we will simply change the load in one of the phases. So let us go for yellow phase. You can see I have changed the load. Now you can find that in this phase, that is in the R phase and B phase, the load values are equal. Whereas in case of Y phase, the load value is different. And now you can find the ammeter value has changed. It is almost 1 ampere. Now if I make another change, you can see again you are having a neutral current. So this shows us that whenever there is an unbalanced load, a neutral current always shifts from zero value, and that is never expected. So while designing a three-phase circuit, we should be very considerate towards this fact that load should always be equal in each of the phases. That means we should always go for a balanced load circuit in case of a three-phase circuit. And that's all about it. If you have any confusions, kindly comment onto the comment box. Thank you.